Now we move to arrays and array comprehensions. Array comprehensions, if you come from Python, is similar to what they call in Python list comprehensions. So what a array comprehension, it's an easy and intuitive syntax to create arrays on the fly. So before you saw something like this, map x squared 1 to that. So this did get us back a vector of squares from 1 to that. We can do the same using an array comprehension. So we put everything inside brackets, and we begin with the expression, so x squared, and we add a for argument, a for keyword, for x equals 1 to 10. So for every x in 1 to 10, do x squared and return this as an array. That's what this expression is doing, and as you can see, we get back a vector of squares from 1 to 10. You can also have multiple inputs. So here it's x times y for x in 1 to 10 and also for y in 1 to 2. And here, the iterations between those two intervals, the x 1 to 10 and the y 1 to 2, they will interleave. So we get back 1 and 2, and 2, 4, 3, 6, 4, 8, and so on. 8, 16, 9, 18, 10, 20. So it's interleaved. So it ports go 1, 1, 2, 2, 2, 2, and 1, 2, and so on in multiple inputs. You can also do conditions. So here I can add an if condition. So bit needs to evaluate it to true or false. So I do x squared for every x in 1 to 10, and I can also use in here. I can use equals or in, so here this also works. I can use equals or in, it's your call. So for x in 1 to 10, only if this evaluates to odd for all of the elements. So this will create an array of squares just for the odd elements for 1 to 10. Now if I run this, I get back 1, 9, 25, 49, and 81. That's the squares of the odd elements from 1 to 10. Then as you can see, this is dependent of the transformation and the inputs that you give. So here on the transformations, and the inputs, they return integers, so vectors of int64. I can change that. I can change that if I want. I can tell Julia to, okay, I want you to do this array comprehension, but I don't want the type that you are returning. I want you to coerce that, to change that into my desired type. Now, for example, if I want that to be float, I pretty much index or repent my array comprehension with a float. And when I do this, it returns a array of floats. And I can also do other things. For example, if I want to complex numbers, Julia has full support for complex numbers. I can do that also. I get back a vector of complex numbers. Of course, all of the imaginary parts are 0. So that's it for array comprehensions. Some users find more intuitive than the map syntax. And also you have a little bit more control, and it's easy to coerce your array type using a desired type here.